In the last presentation, we obtained the hybrid equivalent circuit, and now we will find the expressions for current gain, voltage gain, and power gain. In this circuit, on the input side, I will introduce the source voltage Vs and the resistance Rs. On the output side, I will introduce the load resistance RL. Current IL is the current through the load resistance. Z subscript O is the output impedance. Z subscript I is the input impedance. And first we will find out the expression for current gain. Expression for current gain. Current gain is represented by A subscript I, and the current gain is equal to the ratio of output current to the input current. The current gain A subscript I is equal to the ratio of output current to the input current, and you can clearly see the output current is IL and the input current is I1. So the current gain is equal to IL by I1. IL is equal to minus I2 because direction of I2 is opposite to the direction of IL. So we can also write the current gain as minus I2 by I1. Voltage drop across the load resistance is equal to V2. The voltage drop is equal to V2, and it is equal to IL RL, or we can write minus I2 RL. I will use H parameter equations, and from equation number 4 we have current I2 equal to HF I1 plus HOV2, and in place of V2 we will write minus I2 RL. So we have minus I2 RL. Now I will add HO I2 RL on both the sides, and this will give us I2 plus HO I2 RL on the left hand side, and on the right hand side we have HF I1. I will take I2 common, so we have I2 inside the bracket 1 plus HORL equal to HF I1. Dividing both the sides by 1 plus HORL, we have I2 on the left hand side, and on the right hand side the numerator is HF I1 and the denominator is 1 plus HORL. The current gain is equal to minus I2 by I1, so we will multiply both the sides by minus 1 by I1, and this will give us minus I2 by I1 on the left hand side, minus I2 by I1 on the left hand side, and on the right hand side we have minus HF divided by 1 plus HORL. Minus I2 by I1 is equal to the current gain, so the current gain AI is equal to minus HF divided by 1 plus HORL. This is the expression for the current gain, and this expression is true for all the 3 transistor configurations: the common base configuration, common emitter configuration, and the common collector configuration. Now we will move to the next expression, that is the expression of voltage gain. Voltage gain is represented by A subscript V, and it is equal to the ratio of output voltage to the input voltage. The voltage gain AV is equal to the output voltage by the input voltage, and we can easily find out the output voltage and the input voltage from this circuit. The output voltage is equal to V2 and the input voltage is equal to V1, so we have the voltage gain equal to V2 by V1. The output voltage V2 is equal to minus I2 RL, so we have minus I2 RL in the numerator, and in denominator we have V1. The current gain AI is equal to minus I2 by I1, so minus I2 is equal to I1 AI. I will put this value here, and we have I1 AI RL divided by V1. I will divide numerator and denominator by I1. This will give us AI RL divided by ZI. ZI is the input impedance because in denominator we have V1 by I1. ZI is equal to HI minus HF divided by 1 by RL plus HO. This is the expression for the input impedance. We will derive this expression in the next lecture. The current gain AI is equal to minus HF divided by 1 plus HORL. We will replace AI with this expression and we will replace ZI with this expression, and after the simplification the voltage gain is equal to minus HFRL in the numerator, and in denominator we have HI plus inside the bracket HIHO minus HRHF multiplied with the load resistance RL. HIHO minus HRHF is also represented by del H. So finally the expression is minus HF by RL divided by HI plus del H. This is del H RL. So this is the final expression, and this expression is also true for all the transistor configurations. The next expression is the expression of power gain. We will find the expression of power gain. Power gain is denoted by AP, A subscript P, and power gain is equal to the product of voltage gain and the current gain. We have already obtained the expressions for voltage gain and the current gain, so we can easily obtain the expression for the power gain. The voltage gain is equal to minus HF RL divided by HI plus del H RL, and the current gain is equal to minus HF divided by 1 plus HORL. I will put them in the bracket. So when you simplify this, you will have HF square RL divided by HI plus del H RL multiplied with 1 plus HORL. So this is the final expression for the power gain, and this is all for this lecture. In the next lecture we will find the expressions for input impedance and the output impedance. So see you in the next lecture.